Welcome to the A Plus EdTech podcast. I am your host, Ashley McBride, and in this episode, we're going to talk about computational thinking and computer science with Greg Garner. Greg works at NC State at the Friday Institute, and normally I ask my podcast guests to kind of introduce themselves, and then I edit that out and I rework what they've told me so I get everything that they wanted in there. Greg did such a good job introducing himself, like it really felt like he was practicing it, that I figured I'd just leave it all to him. So we're just going to jump right into the episode, and I hope you enjoy listening to our conversation as much as I enjoyed actually recording it.
Thank you so much.
Of course.
Sorry
Don't
for the
thank
problem.
me until after, and you know that it's like usable, because I don't know. At some point, one of my dogs is probably going to go crazy, or I'm going to say something that is completely inappropriate, or both.
Well, that's the beauty of editing. Usually I try to do a little bit of research prior to talking to people about what they want to talk about. That did not happen. So, so I usually have questions, and I usually email them a week in advance. That also did not happen. So,
All right. No
I apologize. I figured if anybody would understand, it would be you.
Yes.
So, if you would, the first thing I'd like to do is have you kind of introduce yourself and all of the things that you want said about you, and then I will cut that part out and I'll redo it.
Okay.
So, whenever you're ready.
Am I speaking in the first person or the third person?
You can speak in the first person because I'm going to cut it out. So I'm going to actually introduce you.
Okay. That's what I want to know, because like if I have to do this in the third person, then it makes for a great outtake. But
Yeah. Well, if
man,
you
that guy is a jerk.
Well, we're not. I mean, if you want to go in the third person, I can completely just.
All right. Let's see. I am originally from. You don't have to use all of this. You can decide what fits. I'm originally from Kansas.
That was the plan.
Yeah. So I'm originally from Kansas, and I grew up in Texas. I went to school to be an actual rocket scientist, and that didn't pan out. I learned that was not for me, and changed majors. And after a circuitous path, I eventually ended up in the classroom teaching sixth grade math and eighth grade keyboarding, and turned that into seventh grade keyboarding and eighth grade technology applications, at which in the interview for the technology applications position, my boss said, I don't know what this class is, but you can do whatever you want. So that was really kind of the first foray that I had into trying crazy things in the classroom, and just started writing my own curriculum, coming up with interesting ideas and things that I found to be interesting, and then eventually some of my students agreed. Turned that into a position in Austin doing instructional coaching for a school district that was going one-to-one with iPads, and so really had the opportunity to try and explore instructional technology, especially in a one-to-one environment. And then my wife and I were looking for a change, and so we just packed up and moved to North Carolina because we thought it was a cool place to live. And so we moved to North Carolina, and I landed in Chapel Hill Schools and was an ITF for a year until I was recruited by the Friday Institute to join their team. So I've been at the Friday Institute for about 2.5 years, where I work with teachers, principals, instructional coaches, superintendents, and pretty much everybody in between, all across the state, doing any number of capacity building, professional development, professional learning type trainings, as well as a good bit of content development and writing, and we'll toss in a little bit of research as well. And this semester have, for some reason, decided to pursue a PhD and so I am taking PhD classes currently at the College of Design at NC State, where the degree will be a PhD in design, which doesn't actually mean anything just yet. It's a choose your own adventure kind of degree where you have 45 hours of electives and you decide what kind of program do you want to build for yourself. And so it's pretty cool. It's one of the reasons why I picked that program.
That sounds pretty cool. I didn't opt for the choose your own adventure because I guess I'm not the adventurous type. So I want them to tell me what I have to do and just get that doctorate. So
yeah, well, and that was the way I treated my master's. I did a program that the literal reason I picked my master's program was based on cost. It was $5,000 total cost for the entire program. And,
wow. How did you, what?
Yeah, so that was a no-brainer for a classroom teacher that doesn't make a lot of money. That it's like, oh, here's a program that can get me a raise that will pay off my degree in 5 years. That makes sense. Let's do that. So, yep, picked a program based solely on the fact that it was all online and the total cost was $5,000. So sold. But there were no electives. It was you take these classes in this order with a group of about 16 other people, and you all go through the same program at the same time. And so you kind of build this little cohort of friends. So it was an interesting model, interesting experience, and learned a lot. But it definitely was a very different experience than this new one that I'm undertaking.
Yeah, that sounds more like what I'm doing right now. There's like 12 of us, and we just are together for the next 3 years or more. So
yeah, you'll be best friends.
We will be. We already are.
Oh, good.
So, well, thank you. I think I'm gonna just redo a question and let that be your introduction because that was good.
Oh, I just kind of ramble along and especially when people say, "Oh, we'll edit this thing out." I'm like, "Great, then you get the long version, and then you can throw out whatever you don't want to keep."
Well, maybe I just won't edit anything. I'll take the easy way out. All right. So, wow, that's an interesting background, and from rocket scientist to teacher. That's the pay difference alone.
Yeah, if somebody had told me about parent conferences before I had picked education, I might have chosen differently. But on the whole, it's not too bad.
Right, right. Is that why you got out of classroom teaching, was the parent conferences?
Well, actually, what I learned about myself, because I think it's important for teachers to just be reflective practitioners. We know that that's good practice, but it's just really hard to make the time for it in the midst of everything else. But what I learned about myself about my third or fourth year is that I'm a pretty good instructional designer. Like I can create interesting learning experiences, but I'm a pretty terrible classroom manager. I'm not really gifted in the ways of running a classroom and all the detail that's needed, the kind of the structure that's needed. The organizational skills are not there. I did not like calling parents. I didn't like grading papers. I frequently, I started doing project-based learning, not because it was some new cool thing that I was supposed to do from some training that I went to. I did project-based learning because it meant I could go all semester without really grading anything. And then I just had to hunker down one weekend in December and grade everything. So the kind of the administrivia, as one of my bosses called it at one point in time, just kind of wore on me.
That's funny because I actually went to flipped learning before it was a thing just because I didn't want to answer the same questions over and over.
Yeah. So I'm with you. And so I remember in 2009, I went to this conference and I was talking with this guy who was pioneering this flipped learning thing, and he's like, yeah, basically you do the lecture on a video and the kids watch it before they come to class so that when they come to class they can just get to work. And I was like, oh, I already do some of that stuff because I just don't like talking at my kids. Like I would rather work with them in like, one-on-one or one-on-three. This whole like 32-to-1 thing kind of freaks me out. I'm a little more introverted than that.
Yeah.
So
Wait,
I
did
hear
you
you.
just call yourself an introvert?
Oh, I'm an I-15. I took the official test or whatever. So like I can tell you all about it. But yeah, I'm halfway to the halfway to the max of whatever the scale is. Like it's a scale of -30 to +30, and I'm a 15.
Never would have guessed.
Totally. I'm a good actor as well.
Well, so can you honestly, I don't know a whole lot. I was an English teacher. I taught, research papers and grammar most of my career in the classroom. So tell me a little bit about computer science and computational thinking and what those things really are.
Yeah. So right now in our world, we've got this new push that we should teach all these kids to code and we should teach computer science to everybody. And don't get me wrong, I'm totally on board with this. But part of the problem that we're starting to see is we're not creating strong kind of definitions or strong models, mental models for what we mean when we say computer science, when we say computational thinking. It just kind of all blurs together and we say, oh, the kid's on the computer, therefore they must be quote unquote doing computer science or they must be doing computational thinking. And I've been learning a lot in this arena, especially over the last about year and a half. I've really kind of tried to dig into it and really spend more time. I have no formal training in computational thinking or in computer science, but one of the things I've kind of gleaned and have been kind of discovering over the last maybe 18 months or so, one is that computational thinking is not some sort of new thing that we're just delivering to classrooms. It's already there. It's inherent in our curriculum already. And what we're really doing when we say we want to quote unquote do computational thinking is we're actually trying to refine the computational thinking habits of mind that are already present in our classrooms.
Can you give me an example?
Yes. If I can back up the clock a little bit, when a baby is born, the first thing that they really kind of figure out in their brain, the first things that they're really doing is sensory thinking. They're starting to understand the world in terms of hot, cold, right? They can't articulate that, but they're starting to understand their senses. They're starting to input data from the world around them, if we want to call it that. Once they kind of have a grasp of sensory, the next thing that develops is spatial, and part of spatial is volumetric. And so this is where we start making comparisons. We're not trying to measure or quantify these comparisons or anything like that. It is strictly the understanding of hot versus hotter, cold versus colder. We're starting to understand smell at this point. We're only months old at this point, so it is way before we get to language. But this is where you see babies that are starting to understand size differentials at this point. So that's all kind of that spatial thinking. And the next thing that develops is computational thinking, and this is where they start being able to make manipulations. They start being able to understand not just hotter, but how hotter, how much hotter. And they're starting to be able to make more kind of quantified or computational assessments of the world around them. And the last thing that develops is language. So when a baby starts speaking and developing language, what they're really doing is for the first time being able to express the other thoughts that they've already been having, which is fascinating. I just think it's incredible to kind of think about this, and especially that we're hearing computational thinking as this big fancy buzzword that is going to take big initiatives to implement. And what we're really saying is babies do it. We just need to be more explicit about it. So in the classroom, now if we can kind of zoom forward, when we start talking about computational thinking for the classroom, what we're really talking about is how are we acknowledging and providing support for students with regards to computation. How are we supporting them in their ability to manipulate the world around them, to to play and to make combinations? And are we giving them rules and schema and really even grammars? Right. So if we have a set of rules about how a certain thing works, and we change one of those variables within those rules, if we take this set of rules, we would call that a grammar. So if we take and we start manipulating some of those variables, in what ways does it affect the final output? In what ways does it affect the final product? So for a language arts example, if we were to take a limerick, there is a particular grammar for a limerick, right? It follows a particular structure. It follows a particular pattern. And we can identify those patterns. We can think about them computationally. And we understand that as soon as we change something, if we were to change a rule within that limerick, change part of the grammar structure, it would change the limerick. It would change it to perhaps a different form of poetry. It would cease to be a limerick as commonly identified under the rules or the schema that constitute a limerick. And so the computational thinking side of this is being able to understand computationally, how do we manipulate the variables, the rules, the schema, or schemas that affect and kind of structure the world around us. And that's what babies are trying to figure out before they can ever speak. And so what we're saying is, in a classroom setting, we just want to make this more explicit. It's already there. We just need to be able to identify it, need to be able to put language to it. We know that language is later developed than the actual skill of computation. So we need to be able to name and describe and put words to some of these ideas. And so that's really at the heart of what computational thinking is about. And I think the next logical question is, so what in the world does that have to do with computer science?
Okay, yeah, that's if you want to host the show too, that's fine with me. I'll just sit back and record. But what does that have to do with computer science?
The way that I've been thinking about this and the way that I've kind of been framing this is that now that we're talking about humans interfacing with computers, we have to think about language differently. Right. And so when we talk about, making kids code and we talk about programming, those are all linguist type conversations. Those are lingual activities. It's about language.
Then why is it so hard for me to learn computer science when I love language? Why don't I like computer science?
I'm going to say that the reason is rooted in computation. And your mileage may vary, but I would venture a guess that it has to do with a lot of computer science. The first line barrier, the visible barrier, is the language side. And people say like, "Oh, I don't know how to code," and I what blah blah blah, and it gets positioned as, oh well, you just need to learn the language, you just need to learn JavaScript, you just need to learn C# or whatever the language is. But a lot of what makes programming more difficult is this combination between language and computation. And so we have to have mastery over both sets of habits, both of these habits of mind, if you will. We have to be able to compute well and understand how to manipulate the rules and the variables and the schema that control our thinking and that control the world around us, and that ultimately would then control the programs that we're trying to write. And we have to know how to put language to that, to those variables, to that set of rules, or those grammars, so that we can then take the language and make manipulations to the variables, to the grammars, to make it then do what we're trying to do. So the intersection of the computation and language, I think, is, if we can master that in an analog sense, in a non-technology sense, which I would argue that is very difficult just without the technology, then it makes, when we layer in or when we integrate in the technology, it makes it a little bit easier. There's still a learning curve. It still takes practice. It's still a skill. It's still a habit. We know that habits take time to develop, but it's something that we can work on even without computers in front of us. Yeah. Well, and the flip side is that I find that there's a lot of people, a lot of teachers that I'm working with, that as soon as you have them do an analog activity, and one of the tools or resources I really like to use is called CS Unplugged, because it takes away some of the scary technology aspect of it, and I say that tongue in cheek, but it allows you to get to what are the skills that we're talking about, and it really is about, do you know how to communicate what it is that you're trying to do? And if the answer is yes, then we say, okay, that same thing you just did with pieces of paper or with note cards or with playing cards or with random photos that you figured out how to sort in a particular order, if you can now articulate your thinking about why you did that and why you made the choices you made, the transition to computer science, or to being a computer programmer, to being an engineer, is a lot less than you think.
So, so then my question, if doing this is really about habits, and what is hour of code effective?
Yes and no. I'll give you both answers. It's effective to the extent, sure. So hour of code is effective to the extent that it sparks curiosity. It is effective to the extent that it leads to additional conversation. It's effective to the extent that you say, I can do this. If hour of code is only an hour, then I would argue that no, it's not effective. It's not doing its job. And from the outset, it was never intended to be just an hour. The idea was, let's get over the mental block or the mental barrier of, well, it takes a lot of time to do computer science. Well, no, we can start doing computer science in an hour. And so if you can sacrifice an hour, you can start doing code.
How do you put coding or computer science into a classroom, like a regular everyday classroom? Now, math, I can kind of find, but this is something as an ITF I have really struggled with, is trying to figure out how I can get this into the classrooms and make it meaningful in maybe my English classes or in my social studies classes. Do you have any suggestions for that?
There's a book that was recently released called Whiplash: How to Survive Our Faster Future, and it's co-written by the guys that run the MIT Media Lab. So we could make the argument that those are a couple of guys that probably know their stuff. And they talk about, in this book, they talk about coding not as just a skill, right? We don't want to turn coding into the new blue collar. There's been articles written about that we're just going to create code farms, and that's not what we're talking about. What we are talking about is code as a liberal art. We're talking about code as a means of expression. That just in the same way that someone can write a beautiful novel, or that they can compose a research paper that really articulates something interesting that they've learned themselves, we should encourage students to think about code as a means of expressing themselves, and think about code as art, and think about being able to use programming and being able to use, whether it's front end or back end design, as a means for articulating thought and expression. And I think when we do that, we'll start understanding code a little bit differently. One of the downsides, if we stop at hour of code, one of the downsides is that we tend to think of coding as just games. And we don't quite get far enough in to understand how code is about expression, and code is about creativity and original thought. So from a practical standpoint, I would start asking questions not about, here's an interesting activity, how could you fit this in your classroom, but go the other way. Where in your class do you want students to be able to express themselves? What kinds of assignments are you giving where you're asking students to come up with their own original ideas? To the extent that that's true, and to the extent that you've structured your classroom to promote and enable student creativity, is the extent that you have, quote unquote, room for coding.
Do you think that a teacher who doesn't know how to code could figure out a way to implement this so that students could express themselves
Yes, with
via
a
code.
caveat. The caveat is that it might require a different perspective on your role in the classroom. Some teachers, this comes very naturally and they're very comfortable with it. And other teachers, it's a little bit more of a complicated transition. But to really do this well, the teacher has to switch from the kind of arbiter of information, or the one who's there to deliver answers, or the one who's there to imbue a body of knowledge onto their students, and instead kind of turn it around. And they have to be more of the lead learner and the one that asks good questions that they don't even know the answers to, and the ones that when a student says, what do you think, their first answer might very well be, I don't know, but let's find out together. I mean, it's uncomfortable.
So wait, it's okay for the teacher not to know?
Well, let's not tell the principals that. Um, it doesn't look great necessarily on evaluations if you're trying to say, teacher knows their content, and that's a legitimate concern, and it's something that we need to have we need to have honest conversations about, right? I think it's easy to say to a teacher, "Oh, just be the lead learner and just get out of the way and let the students do it." It's a different conversation when your administrator's in your room and you're sitting there saying, "I don't know." That's uncomfortable.
Right. Right. Well, I mean, I can think when I was teaching a freshman and I had an 8th grader who was taking freshman English, and she knew
Yeah.
it better than I did. I mean, I was doing her no favors whatsoever, trying to teach this material to her. And I ended up having to rethink how I was teaching her. And do I think I was completely successful? Probably not in that year. But I know that I was more successful with students later. But I mean, this kid, I think she should have been in college in 8th grade. It was 100% ridiculous
Wow.
that she was even in high school. It was, yeah, she was that kind, like, knew the scientific names of things I hadn't even heard of. But I think you're right that we need to stop worrying so much about being the person who knows it all, and I wonder if there's more power in that. If you just admit that you don't know something, just because then you force the students into trying to figure it out for themselves. And at the end of the day, isn't that what we're trying to do? Is get them to be able to learn things for themselves?
Yeah. The thing that I come back to, and I think about this a lot, especially the older the student is, by the time they've made it to 7th grade, they're schooled, right? They know how the game works. They know how the system
Right.
works. They know that the teacher has the answers, and if they just wait out the teacher will give them the answers. The teacher will bail them out. They know that. I mean, they know how it works. There's no incentive. There's no requirement. There's no real drive for them to really think for themselves. That, frankly, that we have students that think for themselves at all sometimes is pretty impressive to me. It means that there are
Right.
teachers that are doing really good things, right? Like that to me is kind of that anecdotal data that says there's something impressive happening in a classroom where students think for themselves. Um, because the system is geared, not, and this isn't about teachers, the system is geared to uh, allow students to be able to just keep moving on without actually having to do very much of the work at all. I mean, that's how the system is designed. So we're fighting against the system. This isn't about, one teacher versus another, and it's not about, this curriculum or that curriculum. It's not even really about our administrators. It's the system. I don't want to be the fight the power kind of a guy, but we've got an uphill battle, right? Like, it's tough to be a teacher today. And in the midst of all these other conversations, to then also spin around and say, oh, you should be a lead learner. We need to make sure that we're providing support for that. Not just, administrator support, but there needs to be peer support. There needs to be external support. There should be community support. There for sure should be parent support. We've got to make sure that teachers have the support that they need to be successful in these new endeavors.
You said something about support, that teachers need more support. Do you have suggestions for how teachers can kind of get the support, or even suggestions for maybe administrators or districts who are looking to provide that support?
So, again, I'm going to have to give a couple of different trains of thought here. And the first one comes with a disclaimer. I am a punk, and I acknowledge that. I admit that. I'm a rabble rouser. I rouse rabbles. I do not conform to the status quo, and I know a lot of people wear that as a badge of honor. I make my wife very uncomfortable with that because she is pretty convinced that on any given day I'm going to come home and need a new job because I will have said something or done something that has just it's just made the right people, or I guess the wrong people, mad, and they're just done with me. I generally have an attitude of I'm going to do what's best for kids, and I can always find another job, for better or for worse. And thus far, that it's worked out. But I'm not saying that I necessarily recommend that mentality to everybody. It generally creates some uncomfortable late night conversations with your significant other. So that's my first caveat. I say that to say that the best thing I think that people can do is to vocally and loudly advocate for themselves. The squeaky wheel gets the grease. And if you are not repeatedly telling your administrators what you need, they're not mind readers, right? They, at some point, they will say, okay, we got it, stop. And at which point you know that you're getting through. But this notion of like, oh, well, principals should just know that I need more time to reflect, or principals should just know that I need X or Y or Z. They don't. They're just as busy or busier than you are. And if you don't tell them what you need, they don't know. And it's not even
Yeah.
about being, quote unquote, out of touch. I see these tropes about, administrators are out of touch. That's completely ridiculous. Administrators have a pretty good pulse of what's going on, but they don't know what's going on between your ears until you vocalize it. And so it's important to advocate for yourself. And it's important to advocate for your peers. If you're in a PLC meeting and you're talking with your team, and you notice that there's somebody else that's really struggling, and maybe they just need a class period off to just kind of go decompress for a little bit, and you've got a planning period that you could donate, go cover their class. Find ways, come up with interesting and creative ways to support other people. They will thank you for it. They will find ways to pay you back. I have found that to be true, but find ways to alleviate others' discomfort. Find ways to advocate for you and for others. Sometimes it's uncomfortable, but I promise in every case it's worth it.
So I want to go back to that hour of code. And do you have any suggestions to make it more engaging? We are struggling. We're struggling hard, especially at the high school, because the hour of code, and you got to keep in mind it's me and the librarian who are doing this. And we bring in the math classes and we do the hour of code, and then it's all like the Moana coding game, and then the Blockly game, and then we have two Spheros, and that's what we have. And then the kids have to make it to a certain point before they can use the Spheros. But when we broke that rule with one kid who is just completely like, I don't want to touch this computer game, this is ridiculous, and then we hand him the Sphero and he's like, oh, wait a second, I can do this? That's cool. But do you have any other suggestions for making that block of time, especially when you're a coach or a librarian trying to do this and then trying to get it to continue in the classes? Any suggestions on making it more engaging?
Well, yeah. So the thing that I like to come back to is the student creativity side. And what are students making during that time? Is it really just that they are playing a game for an hour, right? That's fine. But I really want to get, just in the same way that, when smartboards first came out and everybody oohed and awed over smartboards. And I don't have anything against smartboards. I think they're fine. But we've got to get past the consumption and into student creation. When iPads came out and kids were just playing video games on them or just doing, whatever other kinds of consumptive activities. That's fine. I don't have anything against that. There needs to be a time where you just kind of play and explore and get comfortable with what this thing is. But at some point, you turn the camera on and you learn how to shoot video and you learn how to edit video, and then you become a publisher. You open up your own YouTube channel. At some point, we'll do the same thing with coding, and we'll stop just doing the games, which are fine, and but we'll stop just doing consumption, and we'll start encouraging creation. What if, and again, not a thing that everybody needs to run out and do, but what if students had GitHub accounts? What if students could start contributing code to the community? What if they could start making their own web pages, making their own content, coming up with their own apps? Like code.org that does Hour of Code also has a tool called App Lab, where you can make an actual app that goes on your phone and you can have one up and running in an hour. So instead of just a game, what if you had students make a game? Scratch has been doing that for over a decade, where they've got 5-year-olds coming up with their own video games. It takes a little more than an hour, but you could start down that path and then use class time to continue, especially if you want to tie the kinds of games that they're making to a particular curricular content, which would be a tremendously interesting activity. Say, for example, what would happen if a history class decided that they wanted to code one of the wars that they were studying about, and you actually had to be a participant, be an actor in that war? What might change? How might students engage differently with the battles that took place if they actually, instead of just having a name date approach to their studies, could turn it around and they were the ones figuring out who fought who and where and how did that go and what were the factors at play and what were the variables that they needed to introduce. And if I'm doing my job right now, you'll start hearing some of those computational thinking tropes coming out. You'll start hearing more about variables and rules and figuring out how those computational thinking habits of mind can apply whether or not you're coding. Right? It really comes out when you're coding. It's a really important addition, but at the same time, I could do that same activity without needing a computer at all. And I think that that's really powerful in the context of students as creators.
Okay, so you said App Lab, which you explained. You said Scratch, which you explained a little bit. And then what exactly is GitHub, just for anybody who's listening?
Yeah, so one of the reasons why I give disclaimers when we start talking about technology and when we start talking about coding and joining a larger community is because there's a real conversation that needs to be had about internet culture. So on the one hand, GitHub is basically a code repository, and it's the ability for you to save and publish little snippets of code to a larger community, and it allows you to also view other people's snippets of code. That, of course, comes with any online environment or any online community kind of awareness, is that just in the same way that you just don't turn kids loose on the internet for, whether it's the comment section of YouTube or some aspects of Twitter, or, you certainly don't want them exploring things like Reddit and 4chan unsupervised. Not that any of those are inherently bad, but they have certain aspects to them that need a lot more training and a lot more coaching. And GitHub's oftentimes the same way, that there are people that haven't quite learned how to be adults, and haven't learned how to respectfully participate in an online environment. So on the one hand, we need to teach our students how to do that. And on the other hand, we need to give them places to be able to publish their work and to be able to show off what they're learning, as well as learn from others. And GitHub's a great way to do that with relation to code.
Well, thank you so much for taking the time to talk to me tonight. I really do appreciate it. So where can people find you? Like, what is your Twitter handle? Do you have a website? Any of that fun stuff?
Yeah, so I'm currently on the Twitters as classroom_tech. And I had a website, and I've actually I'm spending more of my time right now focusing on a monthly newsletter. And so you can sign up for my newsletter at the link on my Twitter profile. or you can go to go.ncsu.edu/Greg. And it's once a month. I send it out on the first of every month. And it's just basically random things that I'm thinking about. And I try to pull a book, a web link, and usually just something fun, and just try to keep it light. Just something for people to think about on the first of every month.
I would again like to thank Greg so much for being on the show. And if you would like to find links to how to contact Greg with his Twitter account and get his access to his newsletter, or if you'd like to look into any of those applications we talked about when we were discussing coding and computational thinking, you can find those in the show notes at aplusedtech.com.